Today we're going to study periodic table in a very easy and convenient way. So, in a long form of periodic table, there are 18 groups and 7 periods. So, at very first, we're going to start from group 1 to 18 and memorize the elements in a very easy and convenient fashion. 1. This is hydrogen, lithium, sodium potassium, rubidium cesium and francium. We call it Halina ki rab se faryad. Halina ki rab se faryad. That's how we can memorize all the elements of group 1. Now group 2. Group 2 it starts from period 2. It's over here. Beryllium, magnesium, calcium, scandium, barium and radium, beta, mange, car, scooter, bap, razi. That's how we can easily memorize all the elements of group 2. Now, this 1 and group 2 elements are called, first elements are called alkali metals and group 2 metal called the alkaline earth metal. Why this is named so? They are formed alkaline. Proceed to group 13. Boron, aluminium, gallium, indium and thallium. Bengan, alu, quite humorous, gajar, in, thala. They are in a thala. So that's how we can easily remember the 30th group. Now the 14th group, silicon, germanium, lead and tin. First tin, then lead. So this is called Kahe Sita Ji Sune Prabhu. Kahe Sita Ji Sunu Prabhu. These are all meaningless phrases, but by remembering this, you can easily remember the 14th group. It is carbon, silicon, germanium, strontium and lead. Now proceed to group 15th and group 15th and group 16th. It's very easy. It's called नेपाल, पाकिस्तान and ऑस्ट्रेलिया सब भिखारी. इसके पास पैसा है नहीं. नेपाल, पाकिस्तान and ऑस्ट्रेलिया सब भिखारी. There is another one. It's very quite funny. It's called Nikhil Pass Sab Bindas. This can be also an alternative term to remember the 15th group. Okay, N for nitrogen, P for phosphorus, arsenic, antimony and bismuth. Now, move on to the 60th group. Usse tera puj. That means oxygen, sulfur, selenium, tellurium and polonium. That's how it's been made. So, if we see properly, we are skipping the first one and the 7th one. Okay, in the first period, these groups doesn't have any element, but the 7th period they have. They are all man-made. So for your board exam, you will need not to study them. Next, proceed to 17th and now move on to the 70th group. This is called the halogens: fluorine, chlorine, bromine, iodine and astatine. Fir, kal, bahar, I, anti. That's how we remember this. Fir kal bahar aayi anti. Fluorine, chlorine, bromine, iodine and astatine. They are all in 17th group. Now the last one, the 18th group. 18th group have all the inert gases. So we will get from the first to from the 7th. And we haven't any shortcuts to remember this. This all comes in a really good phase. So you can easily remember by their name only. Helium, neon, argon, krypton, xenon, radon. Helium, neon, argon, krypton, xenon, radon. They are all present there, and of course 7th one is not necessary to remember. That's how we can go from 1st to 18th group, skipping from 3rd to 12th. Now we are proceed to the last part, the transition elements. Transition elements consist from 3rd to 12th group. There are 10 elements and 4, 5, 6, 7 period. Okay, so let's find out we're gonna study the only first array of transition elements. So that's how it proceeds. Now we are here for the transition elements. At the group, from the group 3rd to 12th, at the period 4, we have 10 transition elements from group 3rd to 12th. If we're starting from the 3rd one, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Now how to remember this? It's very fantastic phrase. Shaktivan करे मना फिर कौन निकाले कुएं से जान. शक्तिवान करे मना फिर कौन निकाले कुएं से जान. शक्तिवान करे मना फिर कौन निकाले कुएं से जान. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. That's how we remember these elements, names and positions by some easy phrase, easy and funny phrases. Okay, now this is your necessity for board exams. In a higher classes, you have to be remember the entire periodic table. So for now, this is for now. Now we are gonna show you the change in characteristics through a period and a group. The first characteristics is atomic radius. If we move along a period from left to right, the atomic radius start decreasing. Why? Because the number of electrons at the outermost orbital start increasing one by one, and the attraction force, nuclear attraction force towards the outermost orbital is greater. So moreover, the atomic radius starts shrinking and it decreases. So along a period, atomic radius decreases. However, on the other hand, if we move up to downwards through a group, the atomic radius start increases, because if we change up to downward, a new orbit starts adding with the atom. So the size of the atom start increasing. Atomic radius along a period decreases and along a group increases. Our next characteristics is ionization potential, that is called IP. Okay, suppose you hold a finger like this, it could be easily removed. If you hold a finger like this, it could be easily removed, easily opened. But if you hold all the 5 fingers like this, the force need to open your hand is greater. So if we have one electron at the outermost orbital, the IP become less. You have less energy. You need less energy to open it. But if you have higher number of electrons at the outermost orbit, you need more force or more energy to open it. So as we move from left to right along a period, the IP starts increasing. The IP start increasing and the IP start increasing. But along a group, a new orbit is added to the element. So the distance from nucleus to the electrons is greater. So we easily remove the electron. So it is decreases. Okay, then what is IP then? What is IP then? Then amount of energy you need to remove a loosely bound electron from the outermost orbit of an element at its ground state is the IP of the element. So IP increases along the period from left to right and decreases along a group. Our next characteristic is electronegativity. Electronegativity is just the affinity towards electron when it's bonded with another atom. The affinity towards electron when it bonded covalently with another atom. So the elements having higher attraction towards electron, having higher affinity towards electron, resulting to having higher electronegativity. So which are the elements which have higher affinity towards electrons? The non-metals. So what we get? We get electronegativity increases from left to right of a periodic table and decreases from up to bottom. So as the size of an atom starts increasing, the electronegativity, the affinity towards electrons start decreasing. So electronegativity also decreases. So from up to down it decreases, and along a period it increases. So this is for now. If you have any other queries, please comment at the comment section, and for more this educational video, please stay tuned with us. Best of luck.